So I'm a social education worker. I'm a systems administrator since 1996. I'm a software developer, liking highly dynamic languages like Ruby or JavaScript or CoffeeScript. I'm a father of two. Next increment is scheduled June this year. Husband of one. So let's have a look to the internet. Once upon a time, there was the net and a few servers connected to them, to the ominous thing, internet. Okay, times were changing. We all have them, smartphones, tablets, all kind of mobile devices got connected to the internet. And nowadays, there are washing machines, fridges, and all kind of other things. And I thought, what the fuck? Why should I need an internet-connected refrigerator or an internet-connected washing machine? So, let's talk about my washing machine. A brief history of my washing machine. Here it is. I had no problems with my washing machine when I lived alone in a small flat. The washing machine was sitting in the kitchen. I was sitting in the living room, and I could hear if it was washing or not. So I didn't forget about my washing machine. Then I decided to marry, to get children, to move to a house. Now the washing machine sits in the floor, and I'm sitting in the living room, and I'm forgetting about the washing machine. I can't hear it. So my washing machine is smart. When I start a program, it tells me I will wash for about 65 minutes. So I thought, okay, that's the solution. I use my smartphone, timer, 70 minutes. It reminds me, I go downstairs, and then my washing machine was lying to me. That's not true. After 70 minutes, it's telling me another 12 minutes, or another 5 minutes, or whatever. So the problem is, it has some fuzzy logic or whatever. It depends on how dirty the laundry is. I can't predict. And I'm forgetting about my washing machine. My wife is forgetting about the washing machine, so the washing keeps sticking in the machine, and we don't get the throughput we need with 2.5 children. So what could we do about that? First, there are commercial solutions. Really, Samsung washing machines can be connected to the internet, and they can send you push notifications to your television, for example, if it's from Samsung, of course, or to your mobile phone. But these are quite expensive. Not only that my washing machine is washing very good, so I don't need a new one, only for these push notifications. And I'm not sure if I can trust a commercial solution. What is this washing machine sending to Samsung about me? And if you read about Samsung televisions listening to you, what you are saying, I don't trust them. So I thought, can I do it myself? That was about 4 years ago. That was expensive, but it would be possible. You could use something like an Arduino, some board like this. You can use a Wi-Fi shield, stacking it to the Arduino. But that's a problem. The Wi-Fi shield at this time was about $80. $80 for a Wi-Fi shield. That was too expensive for my budget, especially for the budget my wife will give me to... Okay, no. So I decided, no, I delay it. Times are changing, and in August 2012, a new star was born, in my opinion. It has a not so good name. It is the ESP8266. It's a tiny little chip. We are talking about this little guy. So this is the whole module, and one of the small black bugs sitting here is ESP8266. So what's it all about? It's a system on a chip from Expressive, a brand I never heard before. These are Chinese guys. It uses a CPU I never heard before. It's a tensor extensor LX3, not ARM or anything like that. But it is a 30-bit CPU clocking at 80 megahertz to 160 megahertz. And what's really, really cool, it has Wi-Fi on board. Bunch of other things that are quite usable. It has GPIO pins, everything you need, and they are dirt cheap. These little guys start at $2 to $3 United States dollars per module, not per chip, for the end customer in single quantities. So I thought that could be a game changer. And I started to tinker with them. So where can we get information about them? There is an unofficial site collecting all stuff. It's esp8266.com. It's not the manufacturer. The manufacturer is here. And of course, you could use Google. And if you look at Google Trends, it's trendy at the moment. If you are curious and want to buy one, where should you do it? A little advertising. Buy them in China. If you buy them in Europe, you will have to pay about $10 per module. In China, it's about a half. So buy them in China. What will you get? You will get such a little guy, or bigger ones. And there is a firmware on board. And this firmware was meant to be a serial to Wi-Fi bridge. So the main purpose, or the initial purpose of these little modules were to connect microcontrollers to the internet. Every microcontroller can speak serial protocols, so you can talk to this little guy and connect your maybe already existing microcontrolled project to the net. It's driven using AT commands, like in the old days when we were using modems to connect to the internet. Well, it has everything you need. It depends what you need, but I think it has everything. But this firmware does not use the full potential of the CPU and the hardware of these little guys. So let's see how these commands look like. AT plus some command. Okay, let me see. If you want to tinker with it on an PC or laptop, you need another part. It's an USB to TTL serial converter. You have to wire it like this. you have to ensure that some connections on the chip, on the module are made. For example, you have to wire the chip enable pin to positive power. If you don't do it, it will not work. So then you can connect this thing. Okay. Is it readable? So I can, here you're seeing what the module is answering to my commands, and I can, for example, say AT, and it has to say OK, so it is connected. With this command AT plus CV mode equals 1, you'll set it to client mode, because this little module can be a Wi-Fi client or an access point, or both. And I've set it to client mode, and now we can do scanning what available access points are here. So we see Android Schmelzer, for example. And if I knew some of the passwords of these wireless LANs, I would be able to connect. So that's what you get if you buy it, if you don't do anything about it. You need a microcontroller, you have to talk to it via these AT commands, and everything is fine. I think it's pretty impressive what you get for $2.50 nowadays. So let's see. Okay. The next level would be flashing these little guys. Why would you like to flash? Of course, you would like to run your own software or custom firmwares on these little things. If you flash, you have to know that you have to put these little modules into flashing mode. So we have to connect another pin from these GPIO pins to another, to ground. So normal mode is this one, only GPIO pin 15 has to be put to ground. And this chip enable pin has to be put to 5 volts, so you can boot from ROM. If you would like to flash, this is the configuration. Or graphically, another connection has to be made from pin 0 to ground. Okay. There is a tool written in Python to flash these things. Command line, I don't want to show it to you. Now we come to the first real example, Hello World. Hello World in microcontrollers, if you're familiar, is blinking an LED. I don't know why, but let's do it. So this is my Hello World. Can anyone see it? It's blinking. So I could tell you everything. How is it done? This was done using the Arduino IDE SDK. It's available for ESP8266. It's still work in progress. Not everything, not every library, not every function is working, but the most important things are. And you have to connect I'll put it in flashing mode, connect it to my computer. I'm not sure if I can. If you can read it. So you are programming in a language that looks and pretends to be C or C++. Not everything is working. But you have two functions, one setup function that's called once and one loop function that's called every time. So in this little hello world example, I'm setting one pin of the usable GPIO pins as output. So I can use it to drive my LED. And I'm writing high and low and waiting for 1 second. And I'm doing that till time stops. Okay. It says uploading. It's flashing it to the chip. If you would see it, there's some LEDs blinking, and when they stop blinking, it's all done. It takes about 20 to 30 seconds. Now it's finished. Now I can disconnect it. Connect again the LED. And it's blinking. The only reason why I connected to my laptop is the power source. I need power for it. Oh. And there is it. Okay, it's not soldered, it's just plug and pray. Okay, let's go back. So if you'd like to program the ESP8266 modules in a language like C or C++, use Arduino nowadays. Don't use the SDK that is provided from Espressif. You wouldn't like it. It's quite complicated. You have to deal with a lot of lowest level stuff, so don't do it. So then, as I said in my introduction, I don't like, I like dynamic languages like Ruby or JavaScript. So I was looking for another way to program these little guys. And I stumbled across NodeMCU. And it's an alternative firmware where you can use Lua to program the ESP8266. You find it here. Don't try the domain only, the name only. You will see a Chinese page. Use index_en.html to see the English translation. So that was my first experience or context with Lua. So maybe it's yours too. It's a scripting language developed in 1993. It's small, simple, but powerful. It's portable, very memory efficient and resource efficient. So it's ideal for be used on a small device. It's often used embedded in games, so why not use it embedded in an embedded system? Okay. NodeMCU and GPIO. NodeMCU has a very weird, or even to tell sick idea of GPIO pins. So if you are dealing with these little guys, it's all about their GPIO pins and how to push data out or get data in these GPIO pins. So you will basically, in every script you write, you will have to deal about GPIO pins. It could be very easy. So you could write gpio.mode1.gpio.output. So it's quite readable. What does it mean? It sets GPIO pin 1 to output. No. Unfortunately, it's 5. These Chinese guys who have written this firmware must have smoked something very wonderful. I don't get the point of that, why they decided to mix the GPIO pins totally up. So what do? You are using this little script of Lua code in every of your little projects. This one maps the GPIO pins, so you can say GPIO1, and it uses 10, I think. I'm not sure. Use it. Okay. If you have the NodeMCU flashed to your ESP8266, you can connect it to the computer, connect to the console, and you can execute Lua directly. You can store scripts on the little device. You can execute these scripts. But at some point, you will want to disconnect this thing from the computer and have it run autonomously. So what will you do? Well, if NodeMCU boots up, it will search for a script called init.lua. If it's available, it will execute it. So this is the way to get something started automatically on this little script. If this script contains any kind of serious error, you might cause this little guy in a reboot loop. So the only way to get out of this might be flashing the firmware again and start over. Or better, have this init.lua script. You can do some things before, you can do some things after, but set a timer. This one says use timer 0. You have 6 timers to use, or 7 timers to use. After 3000 milliseconds, so 3 seconds, do it once. 0 is saying do it once. Start this function, and this function does nothing else than call another script. So with this solution, if you get an error that is causing a reboot loop, you have 3 seconds to switch off the timer. So you connect it to your console, disarm the timer on 0, It's one command, and you're fine. No need to reflash. I highly recommend this. Believe me, you will use it. Okay, let's have a look how Lua scripts look like. This is the script for setting an access point on these little guys. You have to set the mode. In this case, I set it as access point. You have to configure the access point. And this is just for information purposes. This tells you what IP address the access point has, and everything else is done. So you get a DHCP server. So you can connect to this access point with the client, and it's working. Okay. From now on, some examples. Okay, what I did connect this little guy and connected it to the computer and did a listing of what's on it. So there is the init Lua, there is the GPIO shim.lua, there's a web server Lua, an index.html, okay, so let's have a look. This is a little example on how to create a server. Basically a web server that understands get and post. I will connect the laptop. If you want to try it yourself, I think 5 or 4 people should be able to connect to this little access point. This is the page the web server is delivering. And, oops, what's it? Does anybody see? Okay, who is connected? I can blink it. So it's basically everything is running on this little chip. And I do need about 20 to 30 lines of Lua code to implement it. That's pretty cool, I think. And of course, you can use it in your washing machine. I'm using it in my washing machine. My washing machine has one LED that starts to light up when it's ready. It's the door indicator, it's a green light. So what I've done, I've connected one of these little guys, used the power of the LED to drive this little chip. So when the green LED is lighting up, the little script starts, and it's basically making a connection to a push service. It's called push over, and you can create a free account with them and have all kinds of push notifications sent to mobile devices, to desktop clients. You can build groups, so you can send one notification to a group that gets distributed to the smartphone of my wife, to my smartphone, and to my desktop. So we'll never miss our washing machine again. Okay. How many minutes do I have left? 5, 10, 7? 9. Okay. Another example.
Sorry.
Yeah.
The vendor warranty on your washing machine is still
Yeah, that was lost, but it's old enough to tinker with it. It has no warranty left, so no problem. But you could use different approaches. If you have a new washing machine, and maybe you can use a photoresistor to detect the lighting of the LED. You still have to solve the power problem, so you have a decent power supply for this little guy. Another solution would be a motion sensor. It's a little overkill, I know, but people are doing it. So having a motion sensor on a device that's sitting on your washing machine, if your washing machine is sitting still for about 5 or 6 minutes, you can predict that it's finished with its washing. So you will not void your warranty of your washing machine if you use different approaches than me. But I wanted the easy way, and the easy way is use, and one way that my wife accepted. She didn't want to have anything glued or soldered visibly on the washing machine. Okay, another little demo. So this is a temperature sensor. It's not sending data to the internet because I don't have any internet here. So it's just sending it to the console. If I touch the sensor, oh, wrong direction, no, in the right direction it gets hotter. And if you want to see the code, oh shit, holy shit. So that's it. And the reading is basically this. The big function over there is the bit banging to read the sensor over I2C. So the lure is fast enough to do bit banging in software. So quite performant. Okay. My last slide. Thank you. Do you have any questions?
Do you have any experience with the stability of the chip? Because you are booting it up basically every time your washing machine is finished.
Yeah.
Does it run 24/7?
Yeah, it does. I have temperature sensors in every room of my house, and they are running for weeks. So if you, one word probably about power consumption. If you want to use it without a decent power supply, you can put them into deep sleep mode. In deep sleep mode, they don't use virtually any power. But if you wake them up, connect them to the internet, they're using about 250 milliamps, 200 to 250 milliamps, for how long it takes to connect to the access point, and so you will drain the battery very fast. If you, let's say, measure a temperature every 5 minutes, a battery will only last for about a week or 2 weeks. So it's not that low power that microcontrollers are.
So how do you power every room?
Little power supplies, the same you use for charging your smartphones.
What's the next thing you're going to build?
I'm not sure. I'm thinking about connecting the sensors that detect if a window is closed or not to the heating system. So it gets powered off if you open the window or forget to close it. Stuff like that. Okay.
If there aren't any more questions, thank you, Andreas, for your talk. There's actually cake for you as well.
Thank you.
Enjoy. And